Have you ever been stuck in traffic and just wondered, how on earth is a self-driving car supposed to figure all this out? It's definitely not about following a simple list of rules. Today, we're going to dive into the really cool world of deep reinforcement learning. It's the AI technique that's actually teaching cars to learn complex driving skills through trial and error. Kind of like we do.
All right, so here's how we're going to break it down. First, we'll look at the anatomy of the car itself, what makes it tick. Then, we'll get into how it learns from experience. After that, we'll see how deep learning comes in and just supercharges the whole process. And finally, we'll get real about the major challenges that are still ahead on the road to full autonomy.
Because really, that's the absolute heart of the problem, isn't it? Self-driving isn't just about seeing the world. It's about making the right choice, right now, in a world that is just constantly changing. It's one decision after another, and that's the perfect kind of problem for a very specific type of AI.
So, to really understand how a car thinks, first we have to get a handle on how it senses its environment, and then how it can actually act on it. It's a whole system working together from perception all the way to action.
And this pipeline here illustrates that system perfectly. So on the far left, you've got the sense part. Think of cameras, LiDAR, radar, basically the car's eyes and ears. That raw data then flows into the perceive and localize module, which is where it starts to make sense of it all, spotting other cars, pedestrians, and figuring out exactly where it is in the world. From there, it builds this digital map of its surroundings before handing it all off to the brain of the operation, the plan and decide module, and then finally to control, which is what actually turns the wheel and hits the gas.
So let's zoom in on that brain, the plan and decide module. This is where the magic really happens. After the car has a good picture of the world around it, this module takes over. It's in charge of planning the path, figuring out the best trajectory, and ultimately creating the entire driving policy. That's the set of rules that decides how the car is going to behave from one moment to the next. So, how does this brain actually learn all that? Well, it's not by having a programmer sit down and write a rule for every single possible thing that could happen in traffic. That's impossible. Instead, it learns through this really powerful method of trial and error. And that method is called reinforcement learning. You can almost think of it like training a dog. When the agent, in our case, the car, does something good, like a really smooth merge onto the highway, it gets a reward, a little treat. If it does something bad, like slamming on the brakes for no reason, it gets a penalty. You do that millions of times, and eventually it just learns the strategy that gets it the highest score. And this is the absolute key point. The AI isn't given an answer key. It's not told what to do. It has to discover the best moves all by itself, just by trying to rack up the highest possible score in this really complex game of driving. That reward function is everything. Now, this is totally different from other types of machine learning you might have heard of. Like with supervised learning, you might show an AI a million labeled pictures of a stop sign until it learns what a stop sign looks like. But with reinforcement learning, you let the AI figure out what to do at a stop sign by giving it a reward for stopping correctly and a penalty for blowing through it. See the difference? It's learning a behavior, not just identifying an object. But this whole process creates a classic dilemma. The AI is constantly trying to balance exploitation, which is just sticking with the driving strategy that it knows works pretty well, and exploration, which is trying new, maybe even risky maneuvers that could work out even better. If it explores too much, it's dangerous. But if it doesn't explore enough, it never gets any better. It's a tough balance. So what happens when you take this trial and error learning and you combine it with a seriously powerful brain, like a deep neural network? Well, you get a massive leap in what's possible. It's a real game changer. And that combination is called deep reinforcement learning, or DRL. The deep part refers to those deep neural networks, which are amazing at finding patterns in huge, messy amounts of data. This is what lets the car learn its driving policy directly from the raw feed from its cameras and sensors, turning a chaotic traffic scene into one precise driving command, without a human having to step in and simplify things first. So check this out. On the left, you can see the kind of raw, complicated input the AI has to deal with. That grid shows where all the other cars are. And then on the right, that's the super sophisticated path it has to figure out in a split second. That huge leap from seeing the world to making a decision, that's what's being powered by a deep neural network that was trained using reinforcement learning. And researchers are already applying this to some of the absolute trickiest parts of driving. So take merging onto a highway. A DRL agent can actually learn a flexible approach that adapts to whether the other drivers are aggressive or timid, so it can find that perfect gap without being explicitly told how. Or at intersections where you can't see very well, it can learn to creep and go just to be safe. It's being used to solve these really specific, tough, dynamic driving problems. All right, so for the big reality check, if this technology is so incredible, why isn't every car on the road driving itself yet? Well, it turns out the path from a computer simulation to our actual streets is filled with some pretty major roadblocks. And you can really see just how new all this is from this chart. Applying reinforcement learning to self-driving cars is still a very young field. I mean, look at that. The number of research papers on it just exploded after 2016. That means we are still deep in the research phase, with scientists actively trying to solve some huge challenges before this can be rolled out everywhere. So let's quickly break down the 3 biggest obstacles that researchers are really focused on right now: the gap between the simulator and the real world, how efficiently the AI can learn, and the big one, safety. First up is the reality gap. So an AI can become a flawless driver inside a clean, predictable computer simulation. But the real world, it's messy, it's chaotic. Something as simple as a weird glare from the sun or a person doing something unexpected, that can cause a driving policy that was trained only in a simulation to just fail, completely out of the blue. But the good news is, researchers are making some amazing progress here. There are techniques like domain adaptation that are showing huge promise. One study, for example, got the car to perform just as well in the real world using 50 times fewer real-world driving examples. I mean, that is a massive leap forward in efficiency. Okay, number 2, sample efficiency. Right now, DRL often requires a mind-boggling amount of experience. We're talking about the equivalent of driving for centuries inside a simulation just to learn a single task. We have to make the AI learn faster, from way fewer examples, because collecting all that data in the real world is incredibly expensive and, potentially dangerous. And this brings us to what might be the biggest challenge of them all: safety and validation. How can we actually prove to ourselves and to regulators that an AI system that is constantly learning and changing its own behavior is safe enough to be on public roads with our families? This is a huge, huge area of research right now. So here's the big takeaway. Deep reinforcement learning is this revolutionary framework for teaching cars to make complex, nuanced, almost human-like decisions. But the road from the research lab to our driveways, well, it's still being paved. And the biggest challenges are making sure these systems are safe and reliable in the messy, unpredictable real world. And that just leaves us with a final, kind of provocative thought to chew on. As these incredibly powerful learning systems get more and more capable, they raise these profound questions that aren't just about technology and engineering anymore. They're about ethics. They're about responsibility. When an AI that learns by making mistakes finally makes a big one on the road, who's responsible?